All right, 7th graders, we are going to be using slope-intercept form again, but this time we're going to use it within functions. So what are you going to learn? You're going to learn how to write equations in slope-intercept form and how to use those functions to solve real-life problems. Now we're skipping example 1 and going right to example 2. Now tell me, what's slope-intercept form? What is the equation for slope-intercept form? Good. Y equals mx plus b. What does the m stand for? Okay, slope. And what does the b stand for? All right, so now what we're going to do is write an equation of each line in slope-intercept form. So if we have, for example, y equals mx plus b, we first find the slope. Now, once again, there are multiple ways to find the slope, but really, it's change in y divided by change in x. So we subtract the y values. So if I take 3 minus negative 3, which is 3 plus 3, and then 4 minus 0, that's going to give me a slope of 6/4, which simplifies into 3/2. So I start off with y equals 3/2 x, and now I need to find the y-intercept. Well, here the y-intercept is on the graph, so it's going to be minus 3. So my equation is y equals 3/2 x minus 3. So right now I want you to pause the video and do example B on your own. Pause the video. All right, if you did it correctly, you would get y equals, your slope would be negative 3/4 x, and your y-intercept is 2. So you would have the function or the equation, y equals negative 3/4 x plus 2. All right, in example 3, we're going to find the slope and the y-intercept and use that to write an equation. Now in this problem, y equals, and then my slope, mx plus b. Well, we know 0, negative 1 represents the y-intercept, because 0, negative 1 is the point on the y-intercept. And my slope, I'm going to subtract my y's, so let's do 5 minus negative 1, which is 6, and negative 3 minus 0, which is negative 3. That means my slope is negative 2. Therefore, my equation would be y equals negative 2x minus 1. Now example B. What would I do first if I wanted to write an equation? You'd find the slope. So if we found the slope, I can start with either y value. So I'm just going to start with negative 4 here. Negative 4 minus 2 is negative 6. And negative 2 minus 4 gives me negative 6. That means my slope is positive 1. But now I don't know the y-intercept. Now you could graph it, but here's what we're going to do. We know the slope is 1. I'm going to pick a point, and in this case I'm just going to pick 4, 2. You could also pick negative 2, negative 4. That's okay. And I'm going to take my formula, y equals mx plus b, and I'm going to plug in the y value of 2. My slope of 1, and my x value of 4, which is right here. The b is what I still need to find. So now I can use my equation to plug stuff in to solve it for b. So this will give me 2 equals 4 plus b. I subtract 4 on both sides. That gives me a y-intercept of negative 2. Therefore, if I put this all together, y equals 1x minus 2 is my equation in slope-intercept form. Now, in example 4, we're going to write a linear function, f, with the values f of 0 equals 10 and f of 6 equals 34. Now, remember, if f is a function and x is in its domain, then f of x represents the output of f corresponding to the input of x. That means it would be like the ordered pair. If I plugged in 0 for x, I would get 10 for f of x. If I plugged in 6 for x, I would get 34 as f of x. So I can find the slope. The slope, change in y, 34 minus 10 is 24. Change in x, 6 minus 0 is 6. Therefore, my slope is 4. So I know here, 0, 10, that means that's my y-intercept. My equation would be y equals 4x plus 10. Now, if you always wanted to check your answers, you could plug them in. Plug in my other point. Let's plug in 6. 4 multiplied by 6 is 24 plus 10 is 34. But this is incorrect. It is so easy to forget that you have to write a function. And we're using f of 0. That means my function has to be f of x equals 4x plus 10. So we must be careful when we write a function versus an equation. And for our last example, we're going to solve a real-life problem. A linear model is a linear function that models a real-life situation. When a quantity y changes at a constant rate with respect to a quantity x, you can use the equation y equals mx plus b to model the relationship. The value of m is the constant rate of change. That's important. Right there. M is the constant rate of change, the slope. And the value of b is the initial or starting value of y. Example 5. Excluding hydropower, U.S. power plants used renewable energy sources to generate 105 million megawatt hours of electricity in 2007. By 2012, the amount of electricity had increased to 219 million megawatt hours. Write a linear model that represents the number of megawatt hours generated by non-hydropower renewable energy sources as a function of the number of years since 2007. Use the model to predict the number of megawatt hours that will be generated in 2017. Right off the bat, we have to write a function. And what do we write a function of? Here it is. A function of the number of years since 2007. That means f of x. This means f of the number of years since 2007. So x is going to be the number of years from 2007. That means that if I plugged in 0, that would be the year 2007. What's your output in 2007? It's 105 million megawatt hours. Now in 2012, how many years after 2007 is 2012? It's 5 years. So after 5 more years, we have 219 million megawatt hours. So, what's my slope? Well, I can subtract 219 minus 105. That gives me 114 divided by, and then my change in x is 5 minus 0, which is 5. This gives me 22 and 8/10 as the constant rate of change. Now, what does that mean? That means 22.8 million megawatt hours per year. So we know that's my slope. Now, what's my initial starting point? Well, it's right here, 105. So we know that we have as our answer f of x equals 22.8x plus 105. Now we're going to use that model to predict the number of megawatt hours that will be generated in 2017. Well, in 2017, That's how many years after 2007? 10. So a very easy function. So 22.8 multiplied by 10 is 228. Added to 105 gives me 333. So what does that mean? We're going to have 333 million megawatt hours.